we go. This is the recording for Friday, September 20th, after our quiz for 0304. We also green penned and turned in that in-class assignment from yesterday. Now we're looking at 05 systems of linear equations and inequalities. And so I think you'll find this not only familiar, but a little bit easier. We will be graphing, and so I'll maybe wait until Monday, but I'll give everybody graph paper if you need any. Just give me a head nod. Do you need graph paper right now, or you maybe have enough? And I will expect you to use a straight edge when we do this. We're going to use several techniques to solve systems of equations. I'll say the names of the techniques. Maybe you could give me a head nod if you remember these. So we're systems of linear equations. So two lines and the intersection of lines. So do you remember graphically is one method? Graphically, where you graph the two equations and find the intersection. The other one is substitution. Does that seem familiar to you? That's another method you've learned. And then the other one is elimination. Do you remember elimination, where you multiply the equations by like 2 and -3, and then the x's drop out? Give me a head nod. Does that make I think you'll remember it when we kind of go there. And then for systems of inequalities, we only solve those graphically, and because they're a region on that plane. So the substitution method, the elimination method, consistent, independent, dependent, inconsistent. I think, did we talk about those a different day, like at the very beginning when we were taking those pre-tests? These two go together, consistent and inconsistent. If it's consistent, it has an answer. If it's inconsistent, it doesn't have an answer. So consistent means that's two lines and they intersect. Inconsistent is going to mean that they are parallel to each other. If it's consistent, it could also be that it's one line over the other. I don't know how else to draw that. But independent means it has one solution. Dependent means it has an infinite number of solutions, and it's, everything along that line works for either of those. And then, like I said, systems of inequalities will be graphing as we go. So hopefully you wrote that heading and everything. A system of equations, I don't care if you write what the definition is. I just expect you to know this is a system of equations. And I am going to tell you, you're going to do something new to probably all of you, and that is, well, I was going to say multivariable, which is actually true, but more equations than two and more unknowns than two. Just give me a head nod. Do you think you've done that more? Probably not. That's going to be kind of new to everybody. And so this first one is a graphing problem. I think we'll do this one today, kind of get it out of the way. If you need graph paper, I'll bring that around, and I will expect you to have a straight edge. So you tell me if you need graph paper, and take a straight edge. Need this? Ooh. Graph paper? Graph paper? Katie, graph paper? So just a reminder, we're using graph paper and a straight edge. If you're not here, I just gave everybody graph paper if they needed it and a straight edge. So this is solve the system of equations by graphing. I would say generally this is for equations my least favorite method, because it only is going to work great if they intersect at a grid mark. Do you agree with that? Like, easy to find. But at the same time that I say that, it's a very desirable process, because when I do inequalities, I only do them by graphing. So 3x minus 2y equals -6. There's more ways than one to graph a linear equation. I'm going to get it in slope-intercept form. Give me a head nod. You with me on that? So I want to get y alone. I'm going to call in somebody to just walk us through that. You are the person. Go ahead. And tell me what that is. Okay, I'm going to write -3x minus 6, but yep, it's exactly the same thing. And what do I get? Jason, what is the slope and y-intercept? So take a minute, graph that. The y-intercept is at 3, 1, 2, 3, so right there. And then our slope is 3/2. At the smartboard, because I have to draw this line in with this line drawer thing, I just do a lot of points. So I'm going to start right there at 3, and I'm going to go up 3 and to the right 2, up 3 and to the right 2. And then I'm even going to go down 3, 1, 2, 3, and to the left 2, and down 3 and to the left 2, and down 3 and to the left 2, down 3 and to the left 2. Just to make it easier for me to draw the line that I need in here. And, you know, hopefully these are going to match on grid marks as we go. And then our other equation is x plus y equals -2. And go ahead and walk me through getting that in slope-intercept form. Minus x on both sides, what do I get? And Colin, go ahead and tell me what the slope and y-intercept are. Is the what? Okay. And so I'll plot -2. And since that slope is -1, I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. And I'm just going to put a whole bunch of dots. Bless you. And actually, you know, I can tell that it hit there. So that makes me feel happy. And what is the point of intersection, Jarrett? When you're ready, tell me. Well, look at yours. It should cross at a grid mark. Okay. Ethan, where do you think it is? -2, 0. Give me a head nod. Do you agree with that? -2, 0. So the solution is at -2, 0. And what that means is if I put in -2, 0 in that one or the other one, I will get an equation, something that's equal for either one of those, okay? And so that is graphing. And then the next thing we're going to do is go over the substitution method, and I'm going to put it up here, and I'm going to expect that you know the substitution method, and then we'll do a problem. So I'll just go over it really quickly. You solve one equation for one of the variables in terms of the other, and usually this is a good way to do it if we have like a 1x or a 1y, right? Because then we don't have to have fractions. Then we substitute that expression found in step 1 into the other equation to obtain an equation with one variable, and then we solve that equation, and then we substitute back in to solve for that variable. So make sure you know what those steps are. Write yourself a little note, because when we start right in on Monday, we'll expect everybody to kind of be able to do that.